All right, in this video, we are going to work through verifying the following identity. The identity is sine x plus cosine x quantity squared equals 1 plus 2 sine x cosine x. Okay. All right, so generally speaking, what I like to do is start on the more complicated side of the identity usually, right? And the more complicated side is going to be this side over here, sine x plus cosine x quantity squared. All right, when we write something like that, sine x plus cosine x quantity squared, that is really just a shorthand notation for the stuff in parentheses, sine x plus cosine x. Right, what you are doing is multiplying that by itself. So I'm taking sine x plus cosine x, and I am multiplying it by itself, sine x plus cosine x. So that's what this notation means, right? All right, so I'm just rewriting this, right, using a little algebra. And the next thing that I want to do, if I look over on the left-hand side, right, I have a binomial right here and another binomial here, and I want to multiply those out, right? So there's lots of different methods that people will use, right? But, right, I just use the FOIL method, first times first, right? So sine x times sine x is sine squared x. And then outer, right, sine x times cosine x. And then inner, cosine x times sine x, which is the same as sine x cosine x. All right, and then I want to leave a little space over here to write the other side. And then, but to continue multiplying out the left-hand side, it's cosine x times cosine x, right? Which would be plus cosine squared x. All right, and then right-hand side, I am just leaving alone, not messing with it, right? Because we're verifying an identity, not solving for x, so we are working on one side at a time. Okay, so now looking over at the left-hand side about things that I can do, I can see here that I have a sine squared and a cosine squared, so that's always going to make me think of the fundamental identity, right? Sine squared plus cosine squared equals 1. All right, so what I'm going to do is I'm going to write the sine squared and the cosine squared next to each other. And the reason I can do that, right, is because of the commutative property of addition, right? It doesn't matter the order in which you add real numbers, right? You can 3 plus 5 is the same as 5 plus 3, right? And that's true for any two real numbers. The order in which you add them doesn't matter, so I'm going to put those over here. And there's also the associative property that comes into play there, but because we have multiple things being added together. So I'm going to put this over here, the sine squared and the cosine squared, because I know I'm going to be able to use that other identity that I had. And then now looking at what's left over here, the other two terms, I have sine x cosine x and sine x cosine x here. Those are like terms, right? They have the same variables, same exponents, everything looks the same. So here I have one sine x cosine x, and here I have another, right? So one of these plus another one gives me 2 sine x cosine x altogether. Okay? So, and then the right-hand side is just tagging along. All right, things are looking pretty good, right? This 2 sine x cosine x definitely appears over here. And so now you can see the only difference is 1, right? So what I'm going to do is use a known identity, right? This identity right here. And so I'm going to replace sine squared plus cosine squared in the identity that I'm trying to verify, right, with a 1. Okay, so all this stuff here is just replaced with a 1 by using that Pythagorean identity. And I have 2 sine x cosine x. And so you can see that does it, right? I have verified this identity, right, because I have shown that the left side can be, using algebra and the other trig identities, I can transform the left-hand side into the right-hand side. And these are obviously equal to each other. Okay? All right, that is it on this example.